The James Webb Space Telescope is upsetting the apple cart. All of a sudden, we realize that we may have to rewrite all the textbooks about the beginning of the universe. For decades, Pluto has been one of the most mysterious members of our solar system. Ever since its discovery in 1930, astronomers and space enthusiasts alike have wondered what lies on its icy surface, what secrets hide beneath its frozen crust, and what its strange orbit can tell us about the outer reaches of our cosmic neighborhood. We got a tantalizing glimpse back in 2015 when NASA's New Horizons spacecraft flew past Pluto and gave us our first close-up images. Those pictures were breathtaking. Mountains of ice, vast plains, and hints of a thin atmosphere. But as incredible as they were, New Horizons was just a flyby mission. It came, it snapped, and it moved on. For nearly a decade, we've been left wanting more. Now, the James Webb Space Telescope has delivered something extraordinary. Using its unparalleled infrared capabilities, Webb has captured an image of Pluto that is unlike anything we've ever seen before. It's not just clearer, it's deeper. Every pixel seems alive with detail, revealing textures and patterns invisible to any previous telescope. This isn't just another snapshot. It's a window into an alien world that sits more than 3 billion miles away from Earth. So why does this matter? Think of it this way. If New Horizons gave us a postcard from Pluto, the James Webb Telescope is like handing us a high-definition, full-length documentary. Webb doesn't just pass by. It observes, studies, and peels back layers of the cosmos. By pointing its golden mirror segments toward Pluto, it has given us an image that feels less like looking through a telescope and more like standing in orbit around the dwarf planet itself. But the story isn't just about one picture. It's about what this picture represents. For years, Pluto has symbolized the limits of human curiosity. It's distant, cold, and isolated, a tiny dot at the edge of our solar system. And yet, with Webb, that dot transforms into a world. We can now see surface variations more clearly than ever before. Regions of nitrogen ice, hints of shadowed craters, and subtle color changes that suggest complex chemistry. Each detail adds to the narrative of a world far stranger than we imagined. And here's the part that will truly capture your imagination. Webb's infrared eyes don't just take pretty pictures. They reveal temperature differences, chemical fingerprints, and the way Pluto interacts with its thin, tenuous atmosphere. What looks like a frozen, silent world suddenly comes alive with invisible activity. It's like watching a frozen painting shift into a living, breathing landscape. The truth is, we've only just begun scratching the surface of what Webb can do for Pluto. This image is just the opening act. As more data pours in, astronomers believe we could uncover secrets about Pluto's geology, its seasonal changes, and even its hidden ocean beneath the ice. The next time you look up at the night sky and think about the edge of our solar system, remember, thanks to Webb, that edge just got a whole lot closer. But before we dive into what Webb actually found on Pluto, let's rewind the clock. Because to understand why this new image is such a big deal, we need to revisit Pluto's complicated past, a story filled with discovery, controversy, and endless fascination. When Clyde Tombaugh first spotted Pluto in 1930 through a telescope at the L Observatory in Arizona, the world was captivated. Here was a new planet at the very edge of our solar system, a frozen sentinel orbiting in the dark. For decades, Pluto held a special place in astronomy, the little planet that could. Textbooks were rewritten. School children memorized its name as the ninth planet, and Pluto became a symbol of discovery itself. But Pluto's story has never been simple. Astronomers soon realized it was much smaller than they initially thought. At just about 1 m across, Pluto is barely 2/3 the size of Earth's moon. For a long time, scientists were puzzled. How could something so tiny be considered a planet on the same level as giants like Jupiter or Saturn? The debate came to a boiling point in 2006 when the International Astronomical Union (IU) made a controversial decision. They redefined what it means to be a planet, setting 3 strict rules. A planet must orbit the sun, be spherical in shape, And here's the deal breaker. It must clear its orbit of other debris. Pluto passed the first two tests, but failed the third. Its orbit overlaps with icy bodies in the Kuiper Belt, a vast region of frozen objects beyond Neptune. And just like that, Pluto was demoted to a dwarf planet. The world reacted with shock. Headlines blared. Science teachers scrambled. And millions of people felt a strange sadness as though a beloved friend had been unfairly stripped of their title. Even today, some still refuse to accept Pluto's demotion. For them, it will always be the ninth planet. But here's the twist. Losing its planetary status didn't make Pluto any less fascinating. If anything, it made scientists more determined to study it. That determination led to NASA's New Horizons mission, which launched in 2006, the very year Pluto was reclassified. It took nearly a decade for the spacecraft to reach Pluto. But when it finally did in 2015, the world was once again in awe. Those first close-up images revealed towering ice mountains, heart-shaped plains, and a surprisingly active surface for such a small, cold world. Pluto wasn't just a dead rock drifting in the void. It was dynamic, complex, and alive with geological activity. The controversy around Pluto's status also helped fuel public fascination. Suddenly, this icy world became more than just a planet or a dwarf planet. It became a symbol of curiosity, resilience, and our ever-changing understanding of the universe. Science, after all, is not static. It evolves, it questions, and it redefines us. Pluto's reclassification was a reminder that even the things we think we know for certain can shift under the weight of new discoveries. And that's what makes the James Webb Space Telescope's new image so powerful. It's not just about seeing Pluto more clearly. It's about continuing a story that began nearly a century ago. From its discovery to its demotion, Pluto has been at the center of astronomical debates, emotional attachments, and groundbreaking missions. Now, Webb adds a new chapter, one that may reveal Pluto's secrets in a way we never imagined. But what exactly did Webb's powerful eyes capture? What new details emerged when this golden mirror turned toward the distant dwarf planet? The answer is nothing short of breathtaking. When the James Webb Space Telescope trained its 21-foot golden mirror on Pluto, the result was nothing short of astonishing. For the first time, we saw the dwarf planet with a clarity that rivaled and in some ways even surpassed the New Horizons flyby. But this wasn't just about sharper pictures. Webb's advanced infrared instruments revealed aspects of Pluto that no visible light telescope could ever capture. At first glance, the image looked almost surreal. Pluto glowed against the blackness of space with crisp edges, rich contrasts, and a level of surface detail that astronomers have been craving for years. Gone were the blurry, grainy shapes of earlier telescope photos. In their place were fine distinctions between icy plains, rugged mountains, and mysterious shadowy regions near Pluto's poles. Even the famous heart-shaped tomb regio, which captured the world's imagination back in 2015, came into view with new layers of texture and subtlety. But the true magic came from Webb's ability to see in the infrared. Unlike New Horizons, which snapped photos as it zipped by, Webb can linger and study the way Pluto reflects and absorbs heat. This allows scientists to map out the composition of its surface in exquisite detail. In Webb's latest image, differences in nitrogen ice, methane ice, and complex organic molecules leap out with stunning clarity. Regions that once seemed uniform now look alive with variation, almost like patches of Earth seen from orbit. Deserts, seas, and continents made of frozen alien chemistry. Even more fascinating was what Webb picked up in Pluto's thin, fragile atmosphere. New Horizons had already detected hints of haze, but Webb went deeper. Using its spectrographs, it identified faint signatures of hydrocarbons and possibly even subtle seasonal changes. Imagine that. A world 3 billion miles from the sun, so cold its surface is frozen solid, still breathing out gases and interacting with its environment. It's as though Pluto is whispering secrets through the vacuum of space. and Webb is the first instrument sensitive enough to hear them. Perhaps the most jaw-dropping aspect of the new data is how dynamic Pluto appears. Instead of a static frozen wasteland, Webb's view suggests ongoing surface activity. Subtle variations in brightness and texture could hint at shifting ice, migrating frost patterns, and even geological processes bubbling beneath the surface. Some scientists speculate there may still be a subsurface ocean trapped under miles of ice, slowly reshaping Pluto's surface over time. For space lovers, these revelations are thrilling. For scientists, they raise new questions. How active is Pluto really? Could hidden oceans or chemical reactions make it more than just a ball of ice? And what does this tell us about other icy worlds like Triton or even Europa? This crystal-clear look at Pluto is more than just an upgrade in image quality. It's a reminder that even tiny, distant worlds are full of complexity and wonder. Pluto is no longer just a distant dot at the edge of our solar system. It's a world with character, history, and mysteries that could reshape our understanding of planetary science. And yet, Webb's discoveries don't stop at beautiful pictures. The telescope's data has revealed surprising details that challenge long-held assumptions about Pluto's environment. Some of these findings are rewriting what we thought we knew about the icy dwarf planet and hinting at possibilities that could change how we see our entire solar system. If the scrambled 12th frame was the lock, then the question haunting scientists was simple. Where was the key? Some argued the key never existed, that the anomaly was nothing more than noise, a natural consequence of Cassini's systems burning up in Saturn's atmosphere. But others weren't convinced. The data didn't behave like random static. It carried the fingerprint of intent patterns that repeated just enough to suggest design, yet collapsed the moment you tried to force them open. When the quantum AI pushed deeper, a strange feedback occurred. Systems that had handled terabytes of raw space data without issue began to loop endlessly. Processors overheated. Memory caches filled with recursive code. It was as if the missing image wasn't just scrambled. It was actively resisting decryption. That raised a terrifying possibility. The image wasn't meant for us. Or worse, it was meant only for those with the right cipher. Something humanity had not yet discovered. Then came the silence. Every attempt to probe the corrupted frame was followed by outages, as if the signal carried a deadweight effect. Teams called it the hush. Terminals would dim. Fans would stop spinning. For moments at a time, laboratories fell into an eerie stillness, broken only when the power returned as if nothing had happened. Engineers swore it wasn't possible, but it happened again and again. The 12th frame had become more than data. It was now treated like a forbidden relic, locked away, isolated in air-gapped servers, studied only in brief intervals. The longer it was analyzed, the stronger the hush effect seemed to grow. Some whispered that Cassini's last gift wasn't an image at all, but a message.